In video games, we normally think about time moving in one direction, forward, just like real life. Time rarely moves backwards in games, and when it does, it's usually a main mechanic, like in the brain-bending puzzle platformer Braid. This is for good reason. Games have a lot of moving parts, and these can be hard to simulate in reverse, without keeping a log of anything that could affect the flow of time, like inputs from the player or RNG outputs. Think about how a video works. Since all of the frames in a video are essentially images stitched together in order, it would be trivial to simply flip that order. However, video games have to render images procedurally using a bunch of scripts that control different things and have tons of extraneous connections. For example, say the player falls into water in Breezy, and I want to play that in reverse starting from this frame. Well, as for the player itself, we have to think about when the ball fell into the water. If we don't know all the actions that led to this happening, the player could have come from here, or any number of other trajectories. And I'm not even mentioning the particle effects, the sound effects, or any of the other tiny details that go into making this interaction what it is. That's why, in games, it's best to only time travel back to a specific point. This is, in effect, what happens when you save and reload in most games. When you save, the game records the state of all the objects that would be important, like the player's position or inventory. Then, when you die, that state gets reloaded. In fact, I'm already doing just that in Breezy, as I talked about a few months ago with the capture system. However, what I'm planning to do is a little different. I've gone forward to the past, but now it's time to go back to the future. One thing that's been in Breezy since the very beginning is this arrow that shows you what trajectory the ball will have when it goes flying. It was one of the few things I kept from the original Jam version of the game, and one of the even fewer things that ties it to traditional golf game. Well, now I'm modernizing it a bit by actually showing the trajectory the ball will have, rather than pointing in the general direction of the hit. This calls back to not only traditional golf games, but also games like Angry Birds, where subtle differences in the trajectory really matter. Unfortunately, I can no longer just point the sprite towards the vector representation of the hit. I have to simulate it in real time. Luckily on the back end, this is pretty easy to do, just fiddly. As I explained at length before, simulating an object normally goes forward in time, but I'd like to send that trajectory data from the future back to the present. Unity has a pretty useful system to handle things just like this, local physics scenes. First we need to create an invisible dummy ball. I'm not factoring in collision for the simulation since most of the hits are going to be open spaces anyway, and since simulating too many objects would be too performance expensive, even if we do the simulation only once per hit. We have to add a rigid body to this ball, of course, and we also have to give it the same properties as our regular ball. Next, we hop into our arrow handling script and create a new scene to move our ball into. It's imperative that we create our scene with the local physics mode set to 3D physics, or else we'll move everything in our normal scene when we try to move the ball. Next, we need to update the script that renders the arrow. We also have to trigger this from the update method rather than fixed update for some ambiguous reason. Whenever the ball asks us to update the arrow mesh, we just stop the physics auto-simulation and manually simulate hitting our invisible ball, then pull its position and velocity every few simulated seconds, and spawn an arrow pointing where the ball is headed, and voila, we have our arrow. All in all, this is a too important effect. I'm sure I could have gotten away with using this blockier arrow, but that's missing the point. To make a game truly high quality, every aspect must be thoughtfully considered and tweaked. It may seem like the rough side of game dev, and it can be boring, but it can also be incredibly satisfying to see the game shape up and mold to your vision. Anyway, that's all I have to say for today. See you soon.